Right, these are the little ATtiny85 pulsar boards. This one has got the header fitted for programming because it's a sort of test one. Normally on the other one you can see that wouldn't be fitted, but you can still temporarily push in some pins to program if you wish. Both of these have got at the moment, you see that red link fitted there. If that's fitted, it connects the positive supply of the radio channels, normally 5 volts, to the motor input, so the whole thing will work off the battery or the ESC power supply, the battery eliminator circuit. Of course, if you want to use a different power supply for your motor or actuator, you just remove the little link. It's removed now, and you can see then you connect to where the plus symbol is. You connect anything up to 15 volts there. Now, I'll just put the link back in. I'm going to be running it off 5 volts for this demo. So that's the normal arrangement. Obviously you don't have to have these header pins fitted in the end, but I think it's convenient because then you can use one of these simple double end servo leads that you can get on eBay, and you connect it, we'll connect just the channel 1, which is labelled rudder, plug that into the channel 1 of, in this case channel 1 of this receiver, which is, this is a little cheap Fly Sky receiver from Hobby King, but obviously you can use any normal receiver. Now, what I have here, I'll just zoom out a bit. This is a little can you see that? This is a converted servo to work as a Galloping Ghost actuator. I've just removed the later stages of the output gears and added an elastic band to centre it. So I'm just going to connect the 2 wires coming from the motor to the 2 motor pins on here, which again are labelled on the back. Obviously you can connect them either way around, and it would just reverse the action. So that's the 2 motor pins connected, if I can get it in. There we go. If I put that maybe around to that side, I'll just check that this is framed alright. Yeah, I think we can see everything. I don't want that shorting out on this little test stand. I'll put it like that. The only other thing we need is a battery and a transmitter. So I'm going to plug a battery in now. You could plug it into one of the empty spaces on here, but it's just as easy to plug it into the receiver, which is what I'll do now. I'll plug the battery into the receiver and we're ready to go. Now you'll notice that it's not pulsing at the moment, but when I switch on the transmitter and it receives a signal, it should start to go. There we go. So at the moment we've only got the 1 channel connected. I'll just zoom in a little bit more on that. If I give it left and right rudder, you can see it biasing it one way or the other. As I say, at the moment only 1 channel is connected, so obviously we've got no elevator control or power control. This is just the default. But I'm now going to add a 2nd channel. So I put a 2nd lead into this little pulsar board, and I'll plug that into the elevator channel of the receiver. so that I'm shaking the stand while I'm doing this. Right, so now we've got elevator as well, so I can now, up elevator slows it down, down elevator makes it go fast. Still got left and right, of course. That's both together. Now, still, if we switch the transmitter off and it stops receiving pulses, it stops. Transmitter back on, and it starts again. Now, we can connect the third channel, which is this sort of power control channel. Obviously it's not needed, but this would normally go to an auxiliary channel on your radio. I've got it going to a pot actually on this transmitter, so that I can play with the amount of power. But typically you'd have an auxiliary with a switch, and then you'd be able to regulate the power. If I turn the pot down now, that's giving very, very little drive, as you can see. Probably not enough to fly. This is coming up and up and up. Now that's probably too much now. If I start giving it, you see it's going to go all the way around. I'll put it back on about 50%, which is the default. Which, oh no, see, that was a bit much. That's more like 50%. And that suits this motor. Obviously, depending on the voltage you're driving it off and your motor setup, you might need 100% drive. And in fact, the way I'm going to be, the way I'm intending to program these for most people who want one, is to give it sort of 80–90% drive, because that works better for magnetic actuators anyway, and is probably it's more similar to what Tobe and Phil have been doing with their decoders, which are 100% drive all the time anyway. I found that if you go about 80–90% drive, you get much the same amount of throw as 100%, but it does save a bit of battery power, because the sudden reversing of the motor from full one way to full the other is what really takes the current out of the battery. And if you just let it coast a little bit, give it time for the spring or rubber band to take over and begin to reverse it, then it takes a lot less drive and still gives more or less the same throw. And the same is true to some extent of magnetic actuators, although they do need a fair bit of drive to keep them going. So again, even with all three channels connected, if you switch the transmitter off, this receiver stops giving out any pulses, and so it stops. Obviously you've got fail-safe set on some receivers, it would go to the fail-safe setting. That's something you've got some control over. Also, of course, I've left the heat shrink off these boards. I would imagine most people would want them with the headers and covered in heat shrink, but without the programming header fitted. But I'll see what people say on that. Okay, so I'll just switch back on and show you typically how you'd use the power channel. So normally it would be on a switch, and in one position you stop, and in the other position you've got your preset drive amount. Okay, thanks for watching.